Hello, today we will start a new topic, that is trigonometrical identities. Identities are those formulas which are applicable for any angle theta. So suppose if you take theta as an angle, the list of identities are sine square theta plus cos square theta equal to 1, 1 plus tan square theta equal to secant square theta, 1 plus cot square theta equal to cosecant square theta. From these only, by rearranging, you can get many more identities. Then cosecant theta is 1 by sine theta. Secant theta is 1 by cos theta. And cot theta is 1 by tan theta. Next is tan theta is sine theta by cos theta. Cot theta is cos theta by sine theta. The next is secant theta plus tan theta is 1 by secant theta minus tan theta. These identities only you can rearrange and form many more new formulas. Like cosecant theta plus cot theta equal to 1 by cosecant theta minus cot theta. Now, these signs of 6 trigonometric ratios, if you take first quadrant, all are positive here. In second quadrant, only sine theta and cosecant theta are positives. In the third quadrant, only tan theta and cotangent theta are positives. And in the fourth quadrant, only cos theta and secant theta are positives. Now, for each of the 6 trigonometric ratios, we can write domain and range. Domain means the values of theta which you can take, and range, you know the values of y you get. So for sine theta, domain, you can take any number, set of real numbers, whereas range will be from -1 to 1. For cos theta also, you can take theta as any real number, but the range will be between -1 and 1. Tan theta, for theta you can take any real number, but you should not take odd multiples of pi by 2 because there the tan function is undefined. And the range or the graph you can see anywhere for all real numbers. Now for cot theta, theta can be any real number, but you should not take multiples of pi. Range, the graph can be seen everywhere from -infinity to +infinity. Cosecant theta, theta can be any real number, but you can't take multiples of pi. And the graph you can see from -infinity to -1 and from 1 to infinity. Secant theta, theta you can take any real number, but you can't take odd multiples of pi by 2. And range, the graph you can see from -infinity to -1 and from 1 to infinity. Next, for sine theta, the minimum value is -1, maximum value is 1. For cos theta also, minimum value is -1 and maximum value is 1. Or you can write mod of sine theta is less than or equal to 1, mod of cos theta is less than or equal to 1. Coming to secant theta, it will be greater than or equal to 1. or secant theta will be less than or equal to minus 1. Similarly, cosecant theta will be greater than or equal to 1, or cosecant theta will be less than or equal to 1. Suppose if you have sine theta cos theta, how to write the maximum value of it you will learn later, because at present you don't know some formulas. That's why I am not telling you. Later on we will come to this point after learning sufficient formulas. Next, if I give you a function a sin x plus b cos x plus c, then its maximum and minimum values can be taken as maximum, minimum values can be taken as c plus or minus root of a square plus b square. Now, some trigonometric values tables you can memorize, like for 0 degrees, 30 degrees, 45 degrees, 60 degrees, 90 degrees. First you have to write, I'll write with a different color. You have to write 0, 1, 2, 3, 4. And then you have to divide everywhere. But before dividing, you can take square root. You have to take square root everywhere. And then you have to divide by 2 everywhere. So you are getting 0 here, here 1 by 2, here root 2 by 2, here root 3 by 2, and here 1. So these values you got are nothing but values of sine theta. That means sine 0 degrees is 0. Sine 30 degrees is 1 by 2. Sine 45 degrees is root 2 by 2. Sine 60 degrees is root 3 by 2. Sine 90 degrees is 1. Instead of degrees, you can learn the radian measure also. 0 degrees is just 0. 30 degrees is pi by 6. 45 degrees is pi by 4. Then we have 60 degrees, which is pi by 3. And 90 degrees is pi by 2. So after getting the sine values, you can write cosine theta also, but you have to write from the last. 1 root 3 by 2, root 2 by 2, 1 by 2, and 0. Next, tan theta you will get by taking sine theta by cos theta. So 0 by 1 is 0. The 2's in the denominator cancel. Here also the 2's in the numerator and denominator both will cancel. Here 2's in the denominator will cancel. And here you have infinity or undefined. Coming to cot theta, you have to write from the back. Infinity or undefined, root 3, 1, 1 by root 3, and 0. After that, you can write secant theta. Secant theta is reciprocal of cos theta. So take the reciprocal of 1, reciprocal of root 3 by 2, reciprocal of root 2 by 2, reciprocal of 1 by 2, reciprocal of 0. It will be undefined. For cosecant theta, you can write from the opposite side. First you will write undefined, then 2, then 2 by root 2, then 2 by root 3, and 1. So this table is important, you have to learn. Apart from that, there are some more tables, values like 0 degrees, 15 degrees, 18 degrees, of course 30 degrees I gave you. So when you learn the values of sine, first one for example sine. So what you have to do? You will be taking 0, root 6 minus root 2, root 5 minus 1 and 1. Then each one you will be dividing by 2. By 2. Here actually I will tell you one more easy way, and that easy way is each value you will divide by, like, in the beginning 2, in the end 2, but in the middle you have to divide by 4. That will be easy. Similarly, cos theta, if you write, you will be writing first, you will write 4. In the last, you will write 3. In the middle, you will write root 6 plus root 2 and root of 10 plus 2 root 5. The next, you will divide by 4, divide by 4, divide by 4. Here, you have to take root 3 and then divide by root 4. Or instead of doing all these, just you remember, divide by 2. Here the answer will be 1. Here the answer is 0. You can arrange the numbers like this. Not only these, some more angles are there, like 36 degrees, 45 degrees, 60 degrees, 90 degrees. Actually 45, 60 and all I told you. I already told 45, 60 and 90. Left off is just 36 degrees. It is better if I write 36 degrees here only. For sine, you will write 10 minus 2 root 5. I will take square root. And then I will divide by 2. For cos, I will take root 5 plus 1 by 4. So these values also you have to remember. Then we have a table for allied angles. What are allied angles? You will write for minus theta, for 90 plus theta, for 90 minus theta, for 180 plus theta, for 180 minus theta, for 270 plus theta, and for 270 minus theta. I will write for all the 6 trigonometric ratios: sine, cos, tan, cot, secant, cosecant. So before filling this, I have to write a few things. Let me use a different color. Yes, for 90, I will write opposite, opposite. For 180, same. For 180, same. For 270, opposite. For 270, opposite. Now, when it comes to minus theta, it is in which quadrant? Minus theta is in the 4th quadrant, 90 plus theta in the 2nd quadrant, 90 minus theta in the 4th quadrant. Sorry. 90 plus theta in the 2nd quadrant, 90 minus theta in the 1st quadrant, 180 plus theta in the 3rd quadrant, 180 minus theta in the 2nd quadrant, 270 plus theta in 3rd quadrant. Oh, Once again, I made a mistake. Okay, 270 plus theta is in the fourth quadrant. 270 minus theta is in the third quadrant. Apart from that, we have 360 plus theta and 360 minus theta also. So I can write 360 plus theta is in the first quadrant. 360 minus theta is in the fourth quadrant. And of course, for 360, you will write same. For minus theta also, you can write same. So wherever I have in fourth quadrant, only cos and sine, only cos and sine if you see, remaining you can understand. So in the fourth quadrant, cos theta and secant theta are positive, and you will be writing the same, like sine theta negative, cos theta positive, tan theta negative, cot theta negative, secant theta, everything I have to write same. Yes, secant theta is same but positive. Cosecant theta same but negative. This is what I have. Now in second quadrant, only sine and cosecant are positive. I will write opposite. Sine I will write opposite and make it positive. Opposite for sine is cos. Then in the second quadrant, cosecant's opposite is secant, positive. You will write in the second quadrant. So in second quadrant, sine and cosecant are positive, remaining all negative. Opposite of cos is negative sine theta, opposite of tan is negative cot theta, opposite of cot is negative tan theta, and opposite of secant is negative cosecant theta. Then in first quadrant, opposite. In first quadrant, all are positives and opposites. So cos theta, sine theta, cot theta, tan theta, cosecant theta, secant theta. Next in third quadrant, same. And tan and cot are positive, same and positive. Tan theta, cot theta. Remaining all are same and negative. Minus sine theta, minus cos theta, minus secant theta, minus cosecant theta. In the second quadrant, only sine and cosecant are positive and same. So sine is same and positive. Cosecant is same and positive. Remaining all are same and negative. Minus cos theta, minus tan theta, minus cot theta, minus secant theta. Then in fourth quadrant, opposite, and only cos and secant are positive. Opposite, cos opposite is sine, positive. Secant opposite is cosecant and positive. Whereas in fourth quadrant, remaining all are negative and opposites. So negative cos theta, negative cot theta, negative tan theta, negative secant theta. Minus. In third quadrant, opposite, and only tan and cot are positive. Tan's opposite is cot theta, cot's opposite is tan theta. Remaining all except tan and cot, remaining all are negatives and opposites. So minus cos theta minus sin theta minus cosecant theta. Okay, next, the last one, it's third quadrant, so opposite and negative. So minus secant theta. Then 360 plus theta, same and all are positive. So I'll copy same sin theta, cos theta, tan theta, cot theta, secant theta, cosecant theta. 360 minus is also same, but in fourth quadrant, same and positive means cos. Cos theta is same and positive, secant theta is same and positive. Remaining all are same but negative. Sin theta is negative. Minus cotangent theta. Oh, I have to write it down because I have to write same. Okay, tangent same, but in fourth quadrant. So minus tangent theta, cotangent same, minus cotangent theta, and cosecant same, minus cosecant theta. This is how you can make these allied angles table and memorize it. Apart from this, there are some again formulas, addition formulas. Sin A plus B is equal to sin A cos B plus cos A sin B. Cos A plus B formula is cos A cos B minus sin A sin B. Then sin A minus B formula. Sin A minus B formula is sin A cos B minus cos A sin B. Cos A minus B formula. It is cos A cos B plus sin A sin B. Tan A plus B formula. Tan A plus tan B by 1 minus tan A tan B. Tan A minus B formula. Tan A minus tan B by 1 minus tan A will become 1 plus tan A tan B. Next formula is cos A plus B into cos A minus B is cos square A minus sin square B, or cos square B minus sin square A. On the next page, I will write similarly sin A plus B into sin A minus B formula is sin square A minus sin square B, or cos square B minus cos square C. Cos square B minus cos square A. Sorry, cos square B minus cos square A. Then next is, there are some values which we can note it down. 15th point. Cos 75 degrees is root 3 minus 1 by 2 root 2, which is equal to sine 15 degrees. Then tan 75 degrees. Okay, before tan 75 degrees, I'll tell you one more. The next is sine 75 degrees equal to root 3 plus 1 by 2 root 2 is equal to cos 15 degrees. Now I will write tan 75 degrees is 2 plus root 3, which is equal to cot 15 degrees. And cot 75 degrees is 2 minus root 3, which is equal to tan 15 degrees. Apart from this, there are some more sum and difference formulas. That is, 2 sine A cos B can be written as sine of A plus B plus sine of A minus B. 2 cos A sine B can be written as sine of A plus B minus sine of A minus B. Then 2 cos A cos B can be written as cos of A plus B plus cos of A minus B. The last 2 sin A sin B can be written as cos of A minus B minus cos of A plus B. Apart from this, there are some product formulas also. Sin C plus sin D is 2 sin C plus D by 2 cos C minus D by 2. Sin C minus sin D is 2 cos C plus D by 2 cos C minus D by 2. One second. This is not writing neatly. So sin C minus sin D is 2 cos C plus D by 2 sin C minus D by 2. Cos C plus cos D is 2 cos C plus D by 2 cos C minus D by 2. And cos C minus cos D is minus 2 sin C plus D by 2 sin C minus D by 2. Then there are some multiple angles formulas, like I will erase this, some extra overwriting game. So sine 2a is 2 sine A cos A. Cos 2a has three formulas. One is cos square A minus sine square A. The other one is 1 minus 2 sine square x, or the third one is 2 cos square A minus 1. Three formulas are there. Not only these, one more formula is also there. 1 minus tan square A by 1 plus tan square A. Then tan 2A formula is 2 tan A by 1 minus tan square A. Sin 3A formula is 3 sin A minus 4 sin cube A. And cos 3A formula is 4 cos cube A minus 3 cos A. 3 cos A. So from these formulas only we will get submultiple angles or half angles formulas. I will write half angle formula also. 19th one. Like sine A is 2 sine A by 2 cos A by 2. Then cos A is cos square A by 2 minus sine square A by 2. Or from these only we can make a set of formulas. I will take set of formulas. Cos A is cos square A by 2 minus sine square A by 2, or it is 2 cos square A by 2 minus 1, or 1 minus 2 sine square A by 2. Any one of these three formulas. Again, on like rearranging, you will get cos square theta is 1 half into 1 plus cos 2 theta. And sine square theta is 1 half into 1 minus 1 minus cos 2 theta. And tan square, I will write this formula also. Tan square theta is 1 minus cos 2 theta by 1 plus cos 2 theta. Then next, some angle values. That is sine 22 and a half degrees is root 2 minus root 2 by 2. Cos 22 and a half degrees is root 2 plus root 2 by 2. Tan 22 and a half degrees is root of 2 minus root 2 by 2 plus root 2. Or you can write root 2 minus 1. Similarly, sine 18 degrees or cos 72 degrees is root 5 minus 1 by 4. Cos 18 degrees or sine 72 degrees is root of 10 plus 2 root 5 by 4. Then sine 36 degrees or cos 54 degrees is root of 10 minus 2 root 5 by 4. Cos 36 degrees or sine 54 degrees is root 5 plus 1 by 4. All these values you have to by heart memorize. The next some more values are sine 9 degrees is equal to root of 3 plus root 5 minus root of 5 minus root 5 by 4, which will be equal to cos 81 degrees also. Next, cos 9 degrees is root of 3 plus root 5 plus root of 5 minus root 5 by 4, which is also equal to value of sine 81 degrees. Then the next values are cos 9 degrees plus sine 9 degrees will be root of 3 plus root 5 by 2, which will be equal to sine 81 degrees plus cos 81 degrees. Similarly, cos 9 degrees minus sine 9 degrees is root of, this is 3 plus root 5. So this will be root of 5 minus root 5 by 2, which will be equal to sine 81 degrees minus cos 81 degrees. There are some more. Actually, many more formulas are there in trigonometry. That is why many people, they don't like trigonometry. but trigonometry is easier actually. The formulas here are sine theta into sine 60 degrees plus theta into sine 60 degrees minus theta is nothing but 1/4 of sine 3 theta. Similarly, cos theta, cos 60 degrees plus theta, cos 60 degrees minus theta is 1/4 of cos 3 theta. If you use these formulas like shortcut methods, you will remember more easily. Tan theta into tan 60 degrees plus theta into tan 60 degrees minus theta is tan 3 theta. Okay, next formula is cos 36 degrees minus cos 72 degrees is 1 by 2. Similarly, cos 36 degrees into cos 72 degrees is 1 by 4. Next, some formulas can be written like this. Sin A by 2 plus cos A by 2 is plus or minus root 1 minus sin A. Or you can take 1 plus sin A. And sine A by 2 minus cos A by 2 is plus or minus root 1 minus sine A. Or next formula is 26th one. 2 sine A by 2 can be taken as plus or minus root 1 plus sine A plus or minus root 1 minus sine A. Similarly, 2 cos A by 2 can be written as plus or minus root 1 plus sine A minus or plus root 1 minus sine A. So with these, we have learned many formulas. Now we can go to questions. Before questions, there are some shortcut formulas also. If time permits, I will tell you those shortcut formulas, or just we will go through the questions. The first question we will take is yes. This question we will take. If A equal to cos square theta plus sine power 4 theta, then first option A, 1 is less than or equal to A less than or equal to 2. B, 3/4 is less than or equal to A less than or equal to 1. C, 13 over 10 is less than or equal to A less than or equal to 1. And D, 3/4 less than or equal to A less than or equal to 13 by 16. This is what we have to find out. So to find out this, what we will do is we will start with A. That is, we will take cos square theta plus sine power 4 theta, which I will write as cos square theta plus sine power 4, I will write sine square whole square. And so cos square theta plus sine square can be written as 1 minus cos square theta whole square. Or this I can write as cos square theta plus 1 minus 2 cos square theta plus cos power 4 theta, which we can simplify and write 1 minus cos square theta plus cos power 4 theta. So We can write 1 minus a as cos square theta minus cos power 4 theta. That is cos square theta minus cos square theta whole square. So you can take common cos square theta. Left is 1 minus cos square theta. That is cos square theta into sine square theta. So this I can write as sine theta into cos theta whole square. Now I can divide by 2 and multiply by 2. Multiply by 2 here. So I have 2 sine theta cos theta is sine 2 theta by 4. Actually, I will write like this. Instead of writing in 2 steps, numerator is sine 2 theta formula, which is squared. Denominator is 2 square. That is 4. So this is what I got for 1 minus a. 1 minus a is 1 by 4 sine 2 theta whole square. Isn't it? Whatever I wrote here, the same thing I have written again. Nothing new. So 4 into 1 minus a will be equal to sine square 2 theta. Now we know that sine theta will be always between minus 1 and 1. So sine square theta will be between 0 and 1. Sine square theta or anything as such. Here in our question we have sine square 2 theta. So it will be greater than 0 and less than or equal to 1. That means 4 into 1 minus a is greater than or equal to 0, less than or equal to 1. Okay. So I got 4 into 1 minus a greater than or equal to 0 and less than 1. Or 1 minus a will be greater than or equal to 0, less than or equal to 1/4. Or minus a will be greater than or equal to minus 1 and less than or equal to 1 by 4 minus 1, that is minus 3 by 4. I will change all the signs. So it will become 3/4 here and 1 here. So A is between 3/4 and 1 can be taken as the option for this question. Of course, this is long, but if you do it, you can do very quickly. Okay, second question is cot theta plus cos theta equal to P. Cot theta minus cos theta equal to Q. Then you have to find P square minus Q square whole square, and the options you must get are 16pq, 8pq, 4pq, 12pq. So what I will do is I will start with p square minus q square. So what is p square minus q square? Cot theta plus cos theta whole square minus cot theta minus cos theta whole square, because this is given in the question. So what I will have here, I will be using the formula. Which formula? a plus b whole square minus a minus b whole square is 4ab. So the same formula we are going to use now. So here you will have 4 times cot theta into cos theta. So cot theta is cos theta by sin theta, and this is cos theta. So you have 4 cos square theta by sin theta. But still we have to simplify it because we have p square minus q square whole square. So what we got is just p square minus q square, 4 cos square theta by sin theta. So 4 cos square theta by sin theta, I will square it. So I will have 16 cos power 4 theta by sin square theta. Now I will stop here for a while and I will take PQ. What is PQ? P is cot theta plus cos theta into Q is cot theta minus cos theta. So you have A square minus B square, or cot square theta is cos square theta by sin square theta minus cos square theta. So this is cos square theta minus cos square theta sin square theta by sin square theta. You can take cos square theta common. So you'll have 1 minus sin square theta by sin square theta. Or I can write PQ as cos square theta. You can see what you have. Cos square theta, 1 minus sin square theta is cos square theta only, by sin square theta. So this is cos power 4 theta by sin square theta. This is PQ. But already you got P square minus Q square whole square as 16 cos power 4 theta by sin square theta. So you can write P square minus Q square whole square as 16 PQ, which is option A. You can select option A now. If you want, let us see. Where is 16 PQ? Yes, option A. Which question we were doing? Question number 2 we did. Okay, we will go to question number 3. Now what's given here is secant theta minus tan theta is a plus 1 by a minus 1. We have to find what is cos theta equal to. So we know that, I will use a different pen with different color. We know that secant theta minus tan theta is a plus 1 by a minus 1. With the help of this, we can find secant theta plus tan theta, which will be reciprocal, a minus 1 by a plus 1. Now, if you add these two, what you will get? On adding, tan theta will cancel. We will have secant theta being added 2 times. So secant theta plus secant theta together, I can write 2 secant theta, because I'm adding just secant theta. Tan theta I will cancel. And here I will be adding a plus 1 by a minus 1 and a minus 1 by a plus 1. So denominator will be a square minus 1 Numerator will be a plus 1 whole square plus a minus 1 whole square. That is, it will be 2 times a square plus 1. And denominator will be a square minus 1. So, because I got 2 secant theta as 2 into a square plus 1 by a square minus 1. How did I get this? I have used a formula. What is that formula? A plus b whole square plus a minus b whole square is 2 into a square plus b square. This formula. So after using this formula, I can cancel these two and I can write secant theta is a square plus 1 by a square minus 1. But they are asking cos theta. So I have to take the reciprocal, that is a square minus 1 by a square plus 1. This will be the answer and it is there in the option also. Let us go to fourth question. Fourth question is sine power 6 theta plus cos power 6 theta is, oh, okay, I will take one more term, plus k cos square 2 theta is given as 1. Then we have to find what is k equal to. The first option is 1 by 2 tan square 2 theta. Second option is 1 by 4 tan square 2 theta. Third option is 4 cot square 2 theta. And fourth option is 3 by 4 tan square 2 theta. So in order to find the answer for this, I will start with what is given. Sine power 6 theta plus cos power 6 theta plus k cos square 2 theta is given as 1. Now I will write this as sine square theta whole cube plus cos square theta whole cube plus k cos square 2 theta equal to 1. I will write same. Now I will use a formula, that is a cube plus b cube is a plus b into a square minus ab plus b square. This formula I will use for these two particularly. So I will write a plus b into a square, that is sine power 4 theta, minus ab, that is sine square theta cos square theta, plus b square, that is cos power 4 theta. And then I will write k cos square 2 theta equal to 1. Because sine square theta plus cos square theta is 1, directly I can write the left of ones. I will write this. How will I write this? I have to take sine power 4 theta. So I will write sine square theta whole square minus sine square theta cos square theta plus cos square theta whole square. And finally, k cos square 2 theta equal to 1. Now, sine square theta whole square and cos square theta whole square, I am taking only these two terms and I will use a formula. What is this formula I will be using here is a square plus b square is a plus b whole square minus 2ab. I will highlight this. This is the formula I will be using. Okay. So for these two, I will write a plus b whole square minus 2ab. Then I have minus sine square theta cos square theta, and then plus k cos square 2 theta equal to 1. This is again 1. So 1 square is 1, and minus 3 sine square theta cos square theta. So I have 1 minus 3 sine square theta cos square theta plus k cos square 2 theta equal to 1. This one and this one will cancel. Now what I will write is minus 3, and then this sine theta cos theta whole square I will write. And then k cos square 2 theta equal to 0. Now here what I will do extra is I will multiply 2 and divide 2. So that 2 sine theta cos theta I can write sine 2 theta, which is squared, and bottom I have 4 to square. Then plus k cos square 2 theta equal to 0. So I can write k cos square 2 theta equal to 3 sine square 2 theta by 4, or k equal to 3 sine square 2 theta by 4 cos square 2 theta. That means k equal to 3 by 4 tan square 2 theta. This is how we can take option 4 as the answer. So we have done question number 4. Next we can go to question number 5. Question number 5 is saying 2 into sine theta by cos 3 theta plus sine 3 theta by cos 9 theta plus sine 9 theta by cos 27 theta plus sine 27 theta by cos 81 theta plus tan theta equal to, the options are tan 27 theta, tan 81 theta, tan 9 theta, and D, none of these. So first of all, we will start with sine theta by cos 3 theta. So here I will write, first of all, I will multiply and divide something. Like I will take sine theta by cos 3 theta. I will multiply cos theta up and down. I will multiply 2 up and down. This I am doing because 2 sine theta cos theta I can write as sine 2 theta. And then in denominator I am having 2 cos 3 theta cos theta. So this I will change. Sine 2 theta I will write as 2 theta, especially I will write 3 theta minus theta. And denominator 2 cos 3 theta cos theta as it is. Now I will use sine A minus B formula. That is sine A cos B minus cos A sine B. And both I will divide by 2 cos 3 theta cos theta. I'll divide by 2 cos 3 theta cos theta. So here cos theta will cancel. Here cos 3 theta will cancel. And I'm left with 1 by 2 common, tan 3 theta minus tan theta. So this first term I got this. Similarly, I can get the remaining terms also. I'll tell you how. I got sine theta by cos 3 theta. Just now I got 1 by 2 into tan 3 theta minus tan theta. Similarly, I can get sine 3 theta by cos 9 theta as 1 by 2 into tan 9 theta minus tan 3 theta. Similarly, there is one more term, sine 9 theta by cos 27 theta. I can get this as 1 by 2 into tan 27 theta minus tan 9 theta. Lastly, there is one more term, sine 27 theta by cos 81 theta, which I can write 1 by 2 into tan 81 theta minus tan 27 theta. Now, the given expression is 2 into sine theta by cos 3 theta plus sine 3 theta by cos 9 theta plus sine 9 theta by cos 27 theta plus sine 27 theta by cos 81 theta. So I can write 2 into 1 by 2 is there for all. Here I have tan 3 theta minus tan theta. Here I have tan 9 theta minus tan 3 theta. Here I have tan 27 theta minus tan 9 theta. And lastly, I have tan 81 theta minus tan 27 theta. So I can cancel tan 3 theta. I can cancel tan 9 theta, tan 27 theta. So left is just tan 81 theta minus tan theta. But if you see the question, after taking all these brackets one, in the end plus tan theta is also there. So in the given expression, I have plus tan theta outside. So when I write plus tan theta at the end, then minus tan theta and plus tan theta will cancel and final answer will be tan 81 theta. So like this, there are more and more problems which you can practice here. But tomorrow we are going to do trigonometry only, but we will take solutions of trigonometric equations and do more problems on that. Meanwhile, learn the concept, be perfect, and come to the next class. See you in the next class.